There's no make class. Hi? Hi? Do you hear me? Hi? Hi? Do you hear me? Make classification. That is, so let me just go make classification. Yes, so that's really helpful. Scale learn. And so it connects. Got in symbol import random. I don't need. You don't need to understand what I'm doing right now, even though it's really simple. Nothing dumb. I'm just saying. You don't have context, so yeah. If you want context, I'll tell you now that I'm just training myself on training neural network. It's not a neural network. I was just a machine learning algorithm. Sorry for that noise. It was my chair. Okay. Chair was kidding on the floor. Don't ask how. So data sets imports make classification. Oh, watch myself. When I'm very lonely. Sorry if I'm doing that sound. It's my legs hitting the desk. I have a problem. So, I import for yeah from a scale learn dot HB. Model selection. It's model selection, right? So, yeah, model selection. Train. Test. What? From scale. Metrics input. Nice. Did I read? Metric. Right? Yeah. Import. Confusion matrix. I think I got. Oh yeah, pandas. Imports and as PD. So YouTube. I gotta search on YouTube. Sorry if the audio sucks. Make classification. Yes. Thank you. Okay then.
be using the make classification function in order to create artificial data sets that will be useful for testing and understanding and playing with the scikit-learn library. So the make classification function is included in the scikit-learn library, specifically in the scikit-learn.datasets package. In order to import it, we need to execute this first line. An important element here is when we are doing or solving classification problems in machine learning, we typically have a certain amount of features, so feature 1, feature 2, and so on, and then we have a label or class that we want to predict. And typically we have numeric values here, so this is like 12.2, let's say 45, then we have other values, and then we have a 1 or a 0 or a 2, but they represent classes. So 0 might represent a woman, for example, a female, or a 1 might represent a male, or a 1 might represent whether a person is paying or not a loan, and a 0 if that person is not paying the loan. So this represents categories, and when we read this data, they might be encoded as letters like A, B, C, or D, or they might be already encoded as 0 or 1, or something like that. So an important element is that when we are working with real problems, the way this happens is that we load a data set either from a CSV file, or we import the data from a database, or we pull the data from the web, or something else. The essential issue is that we will load data that is already or that already exists, so real data. What we'll be doing here in this video will be something a little different. We'll be using this make classification function to generate artificial data. This won't be real data. You won't be using this function at all in real scenarios.
Yeah.
But it is very, very useful for testing and understanding and knowing what to do when you get a real problem in machine learning.
Sure.
So let's jump into the parameters that we have here. The first parameter is the n underscore samples, which is how many observations I want. In my case, I put 100. Then I have the number of features that I want, 100. N underscore samples, which is how many observations I want. In my case, I put 100. Then I have the number of features that I want, so this will be the number of variables that I will be using. In this case, it will be 2. Then I need to specify how many of them I want them to be informative. In this case, I have 2 of them that I want to be informative, so I put 2 and 2. And then the number of redundant one, which is in my case 0. So naturally, the number of redundant plus the number of informative must be equal to 2. Obviously, an acceptable solution would be something like this. Now, an important element here is that we need to specify how many classes we want. So remember that in the previous examples I said, well, you can have a 1 or a 0 or a female or a male. So certainly you can have more complex scenarios. You can have, for example, 5 classes. So this will be encoded as 0, 1, 2, 3, 4. They might be representing different categories. Now, the important thing is that scikit-learn will enforce a restriction between the number of classes that we use, the number of clusters per class that we use, and the number of informative features that we have. But before jumping into that, let's explain what's clusters per class. So this will tell scikit-learn that we want the observations to be clustered into 2 groups here. I could certainly use 0 here, and all the observations will be like just randomly distributed within each class. But if I specify clusters per class, for example, equal to 2, if I look specifically inside each one of these clusters, I will see, inside these classes, I will see 2 clusters of observations. And the same will happen for clusters for class A and class B, or class 0 and class 1. So I will be observing two clusters. Going back into what I was saying a minute ago, there is a restriction here. So let's see what that restriction does. So if we run this, we'll see that this will throw an error. So here this says that the number of classes times the number of clusters per class. In this case I have 5 times 2, that's 10, must be smaller or equal to 2 and the number of informatives. So this is essentially 2, which is obviously, as you might already know, this is equal to 4. So obviously 10 is greater than 4 and this won't run. So essentially what Python and scikit-learn is telling us is that the number of informative features, or the number of features that are useful, is not sufficient to generate 5 classes and 2 clusters inside each class. So certainly that won't work, but this will work because I will have 2 times 2 will be equal to 4. So this will run, hopefully won't take too long. So here I have my result. So let's see what this looks like. So this will be a tuple containing 2 elements. The first, or both elements, will be arrays. The first element will have the features. We will have 2 columns. So column 1 will correspond to the first feature, and column 2 will correspond to the second feature. And the second element of the tuple will be another array containing 0s and 1s. This is because the number of classes is equal to 2. If this was 3, I would have observed 0, 1, and 2. So we are almost ready, and this data can certainly be used for machine learning classification algorithms. An important element is that I told scikit-learn that both features should be informative. So when I run all the algorithms that identify what are the best variables to retain in the algorithm, those algorithms should, in theory, tell me that I should be keeping both features, because both of them were used to generate these 0s and 1s. And finally, this is a very, very important thing, is how do we extract each one of these components for doing real machine learning. So this is very easy. We can just execute x1 like this, and this will pull the first or the second element here. If I want the features, I can do x0, and then I have the information here. So I can split this very easily, and I can certainly use these 2 arrays in any machine learning algorithm that I want. I have my results.
Well, the make classification is very helpful. Nice. So, data equals make classification in samples. Hold on. Let's say 40 number features. Oh, two. Number formative, it's also 2. Number redundant, 0. Number of classes is equal to 2. Number of clusters per class is equal to also 2. Yeah, so data. Yeah, so oh, it's nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 30, 39, 40. Yeah, so it's exactly 40. Yeah, wow. So this should be x. Every x equals 2 features and corresponds to a y, simple y. So these are the independent variables and the dependent ones. So the machine should get those values as inputs, and if it doesn't get that, it will edit its weights and biases. That's for neural networks. I don't know exactly for regression. But I'm not making a classification problem. I'm making a regression one. Will it work? Frick it. Classifier, yes, please. Thank you. So that's so x equals. Oh my god! Even though I woke up at 9 o'clock, I'm still sleepy because I'm very hungry. So that's the last one. Then the stream is finished. Okay? If anyone is listening, is anyone listening at all? No, I'm the only one. Yeah. Yay. X equals data dot iloc. This should be this. No wait. 0 dot values. Y equals data dot iloc. That's very helpful. I'm very grateful for this. Just cut off the pain of searching for useless datasets just to train my models, my fictional models that have no real world value. Why do I speak like I'm drunk? Maybe because I don't know. So, what? Make it 1. Wait a minute. Who are you? Wait a minute. Who are separated. So what am I doing? Oh God, that's sorry. First of all, X. $29. One. $29. So we had 2 plus 2 enters I walk. Elite beats. So data 0. Data 1. There's nothing here. So what if I extrain? Okay, yeah. We're on the safe side. I hate those long names. And I hate them not being long, because if they shorten it, they make like RFC. It just make no sense. So, yeah, the classifier was RFC. Guess we're done. Random. Does it have random? Date was 43. No, it doesn't have. Where's he? You're serious? Oh, so makes sense. Yeah, it does have that random state. So CLF FET X train in and Y train. Will it work? Yeah, it worked. Yeah, nice. CLF. No, wait. Y pred was CLF dot predict. X test. Nice. CM equals fusion matrix. Y test Y pred, then print. Collaboratory from Google is just a blessing. I mean, well, so the recall is bad, but the precision is high, so yes. It's good. Why have I 4,000 samples? How will it do? Should work. Nice, really nice. So the precision is not high, but who am I to judge? How can we change precision versus recall? Wait, I think I know how to change them. Wait, just let me just research this a little bit. So the recall is bad and the precision is bad. So yeah, they both are bad. Yes. 1 second. Classification, yay. Classification, yay. Spread the cola, yay. Love the cola. What am I saying? So yeah. Cross validation. Bob the Builder. Bob the Builder. Use your mom. Bob, yeah, precision, recall, true negative, false, true positive, false positive, false negative, precision and recall. Well, let's test the precision and recall. You know what? That's a fun thing to do. Man, I'm hungry. And I'm real hungry, man. I should be eating right now, but I'm too lazy to eat, so yeah. From Scalar. Scalar is a savior, to be honest. I mean, it's weird to learn that machine learning, out of all other programming languages, started. It's not a programming. Machine learning started at 1965, I think, with just a project or something to test the camera stuff. I don't know. I'm not good with history, but it's really amusing to think it started in the 1965, right after computers were invented. No, computers weren't invented. No. I mean, right after World War. Just straight up amazing, if you ask me. The problem is it hit a down point, like a coal, like ice age, where it didn't have any evolution. I don't know if that a real world or not. But it stayed really to the ground since when the internet just hit, every data set was on the internet. It was amazing. It's like lots and lots amount of data. Even in the old ages of the internet, it's just amusing, especially with the rise of Facebook. 2010, 2007, I think, with Twitter and stuff like that. And I'm not good with history. If I do anything wrong, just correct me in the comments. Even though no one is watching. I don't really care, so yeah. So I got that. Precision. Again, I hate all words in programming. Yes. As artists. Won't work, right? Won't work. No, it won't work. Okay. Yes. Will work. Yeah. How did I do it exactly? Okay then. X. Y. Test. Y. Red. Let me just print. That's the precision score. 89, not bad, not bad. Nice. How can we hire that? Okay. Oh my god. No, oh god damn it. Print. PS Y test Y pred RS RS full square. I am on fire today. What? Stir. Python is a blessing. It's just amazing. Yeah. Worked. Yes, thank you. So yeah, the precision is high. The recall is high as well. How can we hire it? Let me just research even more. The F score. I don't care about the F score right now. So the higher the precision, the more the recall. What should we do? Should we hire the precision or should we hire the recall? I'm confused. What should we hire? How about we hire the precision just for fun? Yeah, we should hire the precision. Wait, let me just do some more research. So the thread hole. So yeah. Let me hire the thread hole, please. Why print? The rest, no, I'm just make TH for short. 200, just to test it. Why have again? It's a decision. I'm just too tired. You know what? Let's end it here. Thanks for watching, guys. I truly appreciate it. Truly appreciate it. Just amazed that no one even watched it. So, yeah. Bye.